Is this possible? SpaceX's Starship as a space telescope. Is this a good idea? What's the future of Starship? The third orbital Starship is almost ready. Why was it moved? The Martian helicopter encounters a massive issue. Can it be saved? And the mystery of the Japanese lander is solved. Did it really land upside down? My name is Felix. Welcome to What About It? Let's dive right in. Starship updates. SpaceX is hard at work building a future that is hard to wrap your head around. Back at Starbase, the teams are tirelessly working around the clock to make Starship, a rocket set to redefine humanity's capabilities in space, operational. In this episode, we'll dive into some fascinating future concepts for Starship, but first let's catch up with the current developments. Both the booster and ship designated for the third launch are being prepped at the production site, inching closer to their rollout. Booster 10, the next one to fly, has been waiting in the Mega Bay since January 2nd. Similar to the previous Super Heavy prototype, the hot staging ring for this booster was removed in order to allow for work around the forward dome area. This is where components like the grid fin motors are installed. Given that these had to be replaced just before the last launch, the Starbase team might have implemented improvements to avoid such issues in the upcoming third flight campaign. Their work concluded by January 26th, as evidenced by the reinstallation of the ring on top of the booster, captured in stunning detail by our photographer John. However, our view of the Super Heavy was partially obstructed. SpaceX has finally installed a part of the Mega Bay door. This door mechanism appears to be similar to the ones used at the Vehicle Assembly Building at Kennedy Space Center, where they open in sections rather than as a single long panel. Interestingly, the material used for the Mega Bay door appears to be some kind of fabric. While this could be a temporary solution, I wouldn't be surprised if this is the intended permanent design. The use of fabric could offer practical benefits, such as a simpler opening mechanism and a reduced maintenance compared to a more traditional rigid door. The primary purpose of the Mega Bay door is to protect the prototypes from dust contamination and shield the building's interior from wind. Since the doors aren't required to block anything from entering, a more durable material might be an overkill. The installation of this door marks the beginning of a new era at Starbase. Build quality and construction speed will very likely benefit from this move. What are your thoughts on this? Do you believe that this is the final version of the door, or will they opt for more conventional panels in the future? Share your opinions in the comments. In addition to the next orbital booster receiving its final touches, Ship 28 is also progressing steadily toward flight readiness. After a 3-week stay in the high bay, Ship 28 was moved out on the night of January 26th. Sometime later, Ship 26 was removed from the engine installation stand, making way for Ship 28 to occupy that spot, as captured in our aerial images thanks to Redline helicopter tours. The reasoning behind moving Ship 28 back to the Raptor stand remains a bit of a mystery. It could be that we'll see a Raptor engine swap, or it might simply be a convenient location to park the ship ahead of its rollout. While we're at it, how about you go see all of this yourself? Book your own ride at Starbase and see these things in person, or just enjoy one of the most incredible views in the world. Go to redlineheli.com/Felix. You'll find the link in the description as well. I promise you won't ever forget this. As we're already in the air, let's discuss another massive upgrade to the city of Starbase. Yep, Musk promised this a while ago. Starbase is turning into a city. Previously, we discussed investments like a restaurant and a shopping mall situated between the production site and Massey's test site. This doesn't seem to be all. Now the focus shifts to a new project, a massive parking facility creatively named the SpaceX Production Site Parking Garage. Fancy, I know. This project envisions a 6-tier parking garage sprawling over an area of 270,000 square feet, or about 25,000 square meters. By rough calculations, assuming an average parking space occupies 162 square feet, or about 15 square meters, and about 75% of the garage area is dedicated to parking, we could see approximately 1,250 parking spaces. The garage is intended for Starbase workers, private land, and not for public use. Its proposed location near Remedios Avenue, a recent acquisition by SpaceX, suggests it might be built close to the existing facilities. One potential site could be behind Mega Bay, where the current land isn't used that efficiently. The need for such a parking facility is evident from photos showing cars parked haphazardly around the site. This chaotic parking situation complicates transportation and poses risks to pedestrian safety. With SpaceX's workforce continuously growing to match the increasing launch cadence, dedicated parking is a logical next step. As Starship production accelerates, we're likely to witness more innovative projects designed to enable space exploration. Looking at the future of Starship, one of the most straightforward applications is, of course, deploying cargo using its payload bay. Starship is unquestionably designed to carry massive payloads, including large satellites and cargo destined for the Moon and Mars. However, the reality is that most satellites launched today are relatively small. While lower launch costs might encourage the development of larger satellites, we're likely to see a considerable number of smaller satellites needing deployment in the near future. This demand could lead to Starship missions similar to Falcon 9's transporter missions. We might see SpaceX or other companies develop hubs or tugs capable of handling hundreds or even thousands of small satellites in a single mission. Furthermore, there are possibilities for specialized transporter missions, in which Starship launches 3 or 4 big satellites, each with its own propulsion module. Like the recently announced Helios space tug designed by Impulse Space. As the market begins to recognize Starship's capabilities, we might witness the boom of truly massive satellites. Take the James Webb Space Telescope as an example. It was folded like an origami to fit within its launch fairing, only to unfold into a larger structure in space. Imagine scaling this concept to fit within Starship's payload bay. This is not just speculation either. One such ambitious project is the Large Ultraviolet Optical Infrared Surveyor, or LUVOIR, poised to be James Webb's successor. Designed to fit in an 8-meter wide fairing, LUVOIR would deploy a mirror over twice the size of James Webb Space and a sun shield stretching up to 70 meters or 230 feet. These dimensions are staggering. But why stop at just deploying telescopes? Why not transform Starship itself into one? Believe it or not, this concept is more than just a hypothetical idea. Elon Musk has mentioned that they are working on converting Starship into a telescope a few times now, though specific details about this concept remain a rare sight. Imagine a scenario where, instead of allocating space for payload adapters and related equipment, a large 8.5 meter or 28 foot diameter mirror is directly mounted inside the body of a Starship. This approach could significantly reduce the cost of manufacturing such a telescope, possibly allowing for a whole fleet of them. While it may not rival the scale of the ambitious LUVOIR project, we're still talking about a telescope with the potential to achieve a resolution 10 times greater than that of Hubble. A resolution of this kind in the visible light spectrum would be groundbreaking. Beyond its applications in space science, Starship could also play a pivotal role in the emerging market of commercial space stations. There are already at least 2 companies planning to utilize Starship for this purpose. The first is Gravitics, which is developing 8-meter or 26-foot modules that can snugly fit inside Starship's payload bay. These modules are designed to function as standalone space stations or can be combined to create large orbital complexes. And this isn't just a concept on paper. They've already constructed a test article for pressure tests. And they've also started work on maneuvering thrusters to be able to hold the station in a stable orbit once launched. Their work on the so-called space armor, designed to keep the station safe in space, is far along as well, including tests. Another company, VAST, is currently focused on Haven 1, a space station designed with Crew Dragon in mind. Their plans also include developing a larger Starship-class module targeted for launch by 2028. Further down their roadmap, they envision a 100-meter spinning space station set for deployment in the 2030s. Starship itself could even be transformed into a space station. NASA announced last year that they are conducting an unfounded study in partnership with SpaceX to explore the feasibility of converting the upper stage into a self-sustained station. Finally, there's a category of projects that, while technically feasible, may never see the light of day. One such idea involves repurposing ships as lunar habitats, a concept proposed in 2021 for the Solutions of Construction of a Lunar Base project. The goal here is to speed up lunar base construction from decades to just a few years. And the concept is pretty straightforward. Once a lunar starship lands on the moon, it is connected to a specialized hinge and cable system. This allows the ship to be placed on the ground horizontally. Following this, the fuel tanks are cut and repurposed into habitable spaces, accommodating crew cabins, storage areas, and research facilities. After outfitting the interior and attaching 2 airlocks, the entire structure is pressurized. The final step involves covering the ship with about 5 meters or 16 feet of lunar regolith, offering protection against radiation and micrometeorites. While this idea is intriguing, it seems more likely that we'll initially see starships being used as bases in their vertical orientation. Another imaginative yet currently impractical concept is experimenting with Starship to create artificial gravity. This would involve connecting 2 ships with a strong tether and spinning them to simulate the gravity of Mars, Moon, or Earth. Physically possible, yes, but the risks and potential dangers make this a daunting challenge. If balance is lost between the 2 ships, this turns into an unpredictable death trap in space. Finally, there's the ambitious vision of a von Braun-type station, a concept originally proposed by Wernher von Braun himself. This design features a massive rotating wheel in space capable of generating artificial gravity akin to Earth's. Such a station could serve various purposes: a luxurious space hotel shuttling guests to and from Earth via starships, or a refueling depot for starships en route to Mars. Though bordering on science fiction, it just goes to show the endless potential of Starship. Which of these Starship concepts do you think will happen first? Do you have any other innovative ideas on how Starship could be utilized? Leave them in the comments. Go wild. I'm always eager to read your thoughts and ideas. Now here's a little task for you before we continue with the news. YouTube may have unsubscribed you without your knowledge. This has happened to thousands of Y viewers, and it can happen frequently. Please double check that you've hit that subscribe button so that you don't miss our updates. And while checking, hit the like button and consider becoming a Y supporter for exclusive SpaceX updates. With it, you get access to daily Starbase photo galleries, now including orbital, aerial, and ground photos of SpaceX's progress, and countless other extras on top. And no matter how much you decide to give, everyone gets the same supporter content and access. You decide what you want to give. Check our new website as well. Launch previews, road closures, the latest weather reports, and our multi-stream viewer, whataboutit.space. The link to our Patreon page and the new website is in the description. Thanks to all the supporters who help fulfill dreams for our team. We can't thank you enough. You rock. As we go back to the news, we have to revisit the topic of Ingenuity, the Martian helicopter. Cause since the last episode, we've had a major plot twist. It appears that the 72nd flight of this helicopter unfortunately marked the end of its groundbreaking mission. To recap from our previous episode, a mishap occurred during a test flight on January 18th. The Mars rover Perseverance unexpectedly lost communication with Ingenuity, prompting an emergency landing for the vehicle. And initially it seemed that Ingenuity had landed safely. However, when it later transmitted its data back to Earth through Perseverance, scientists at JPL made a disheartening discovery. The first images indicated that approximately 25% of one of the helicopter's blades was missing. Further analysis confirmed damage to both rotors. What happened? This new information implies that the loss of contact wasn't just a matter of Ingenuity moving out of Perseverance's line of sight. It is likely that the communication dropout either resulted from or directly led to the rotor damage. Unfortunately, no communication means no telemetry, so the exact sequence of events remains a mystery. While JPL scientists have formulated theories, without the specific data from the incident, they can only hypothesize. One theory is that Ingenuity's current location, characterized by its featureless terrain, might have confused its navigation algorithms. They rely on distinct terrain features for reference. The lack of these points could have caused an aggressive tilt, leading to a rotor striking the ground. Despite this unfortunate conclusion, Ingenuity's accomplishments are nothing short of amazing. Originally designed for just 5 flights, this small but mighty Martian helicopter accumulated over 2 hours of flight time across 72 missions, covering nearly 17 kilometers or about 10.5 miles and reaching a peak altitude of 24 meters or 79 feet. All of this was achieved despite the red planet being a terrible place for powered flight. Mars boasts an atmosphere only about 1% as dense as the one we have on Earth. With such thin air, generating lift is quite challenging. JPL engineers had to innovate and adapt to these Martian conditions. To generate sufficient lift in this sparse atmosphere, they designed Ingenuity's rotors to be unusually long and capable of rotating at extraordinary speeds. While a typical helicopter rotor on Earth spins around 500 times per minute, Ingenuity's rotors could reach speeds of up to 2,800 revolutions per minute, nearly 70% of the speed of sound. This required the rotors to be strong but also lightweight. To achieve this feat, they were constructed from a foam core wrapped in a carbon fiber layer weighing a mere 35 grams or 1.2 ounces each. However, the greatest challenge was managing the vehicle's mass. Despite Mars's gravity being only 38% of Earth's, the reduced weight wasn't nearly enough to counterbalance the insane amount of air that had to be moved to fly. The engineering team at JPL had to design Ingenuity to be as lightweight as possible, with its total mass being just under 1.8 kilograms or 4 pounds. And yet this was enough to fit landing legs, dual rotors, 2 cameras, solar panels, an onboard computer, batteries, and a heating system to withstand the frosty Martian nights. Moreover, Ingenuity required lots of complicated software to navigate the Martian terrain. During flights, it constantly scanned the landscape, adjusting its flight path in real time. While its flight missions may have concluded, its power and camera systems remain operational. This opens up possibilities for the JPL team to reuse it for different scientific objectives, such as studying the effects of Martian dust being disturbed by the rotors. Ingenuity, your contributions to space exploration have been monumental. Thank you for your service. Now let's shift our focus from Mars to the Moon, where another space hero, the Japanese Slim lander, experienced difficulties during its mission. What's the real story here? The last time we discussed it, the details of its lunar landing were shrouded in mystery. However, the Japanese Space Agency has recently provided some insights into what actually happened, and the situation is more complex than initially thought. The landing process went flawlessly until the spacecraft was about 50 meters or 165 feet above the lunar surface. At an altitude of 6.2 kilometers or 3.8 miles, Slim moved to its vertical descent phase, using 2 engines to decelerate. Yet just 50 meters or 165 feet above the Moon's surface, the propulsion system encountered a catastrophic failure, losing 55% of its thrust. Shockingly, images captured by Slim show an engine nozzle lying on the lunar surface, indicating severe damage to one of the engines. There was quite a bit of force involved to lose an engine nozzle, and this had 2 negative effects on the mission. Firstly, with one engine gone, the remaining engine could only counteract lunar gravity, meaning Slim couldn't decelerate, but merely maintain its velocity at 2 to 3 meters or 6 to 10 feet per second. Secondly, due to the engines being mounted at an angle, the loss of one engine caused the spacecraft to experience lateral thrust, something you rarely want to see during a moon landing. Despite the propulsion system failure, Slim managed to land only about 55 meters or 180 feet away from its intended target. If the engine hadn't failed, it's estimated that the spacecraft would have landed within 10 meters or 33 feet of the target. The mission's main goal was to land within 100 meters or 330 feet off the target, so the mission was successful. Just 5 meters or 16 feet above the lunar surface, 2 payloads on board Slim successfully deployed. The first, LEV-1, is a 2 kilogram or 4.5 pound robotic explorer that utilizes a unique method of locomotion. Unlike traditional rovers that use wheels, LEV-1 moves by hopping, similar to a frog. It also played a pivotal role in the mission as the communication relay for the second rover, LEV-2, also known as Sora-Q. It's essentially a small spherical robot with a camera. It moves across the lunar surface using the 2 halves of its body as wheels. Despite being developed by a Japanese toy manufacturer, not a joke, Sora-Q has provided us with actual images of the lander, confirming engine loss. It also looks like the main menu screen from Kerbal Space Program. Currently, due to its landing orientation, the lander isn't receiving enough sunlight to power up safely. However, this is expected to change as the sun's angle shifts in the coming days. Once the solar conditions improve, the lander should be able to continue its scientific operations. This achievement by JAXA's engineers is nothing short of extraordinary. It literally landed on its nose and it still works for the most part. That's it for today. Remember to smash the like button, subscribe for more awesome content. This is what fuels the algorithm and it helps us immensely. Check out our epic shirts in your favorite Space Nerd store. A link is in the description. And if you want to train your space IQ even further, watch this video next to continue your journey. Thank you very much for watching and I'll see you again in the next episode. With an ohololo by instead of Superveyor. Yes.